Hey everyone, and welcome. Today we're going to pull back the curtain on the invisible rules that control literally everything that moves, from a tiny marble rolling across your floor to entire planets orbiting a star. We're talking about Newton's laws of motion, and you'll be amazed at how these three simple rules run our entire world.
So, to get us started, let me ask you something you've definitely felt before. You're sitting in a car, waiting at a red light. The light turns green, the driver hits the gas, and bam! You feel like you're being pinned to the back of your seat. So, why does that happen? It's not some kind of magic, I promise you. It's pure physics. Believe it or not, the answer to that feeling, and so much more, comes down to three powerful, almost elegant rules figured out by Isaac Newton hundreds of years ago. You can think of them as the official rulebook for how everything in the universe moves. Okay, let's jump right into the first rule. We're going to call this one the lazy law. Now, its official name is the law of inertia, but trust me, our nickname really gets to the heart of the idea.
So what is inertia? Well, it's pretty simple. It's just the idea that objects are kind of lazy. They want to keep doing whatever it is they're already doing. And this, right here, is why you felt pushed back in the car. Your body was at rest, and it wanted to stay at rest, even when the car decided to lurch forward without it.
And you know, inertia is a two-way street. An object that's not moving, like a toy car just sitting on the floor, is going to stay right there. And an object that is moving, like a soccer ball rolling across the field, is going to keep on rolling. The only thing that changes the situation is an outside force, like your hand giving that car a push, or the friction of the grass finally slowing that ball down. Okay, so that's law number one. It's all about what happens when there's no force. But what happens when you do apply a force? Well, that brings us to the second law, which we'll call the pushy law. Now, this is something you already know, deep down. You live it every day. The second law just puts a name to it. That heaviness is what scientists call mass, and the push is what they call force. So to get something with a lot of mass to speed up or accelerate, you've got to give it a bigger push. Just picture it. You're pushing an empty shopping cart. It's a piece of cake, right? You can get it rolling fast with just a little nudge. Now imagine that same cart is loaded to the brim with groceries. You've really got to lean into it, right? You have to apply a much bigger force to get it moving at the same speed. More mass needs more push. It's really that simple. And this is where that famous equation that you may have seen before comes in. Force equals mass times acceleration, or F equals ma. Now don't worry, there's not going to be a quiz, but it's amazing how this one little formula perfectly describes the pushy law and connects force, mass, and how fast something speeds up. It's one of the most powerful ideas in all of science. All right, time for our third and final law, and honestly, this one might be the most fun of them all. We're calling it the bouncy law, and it's all about action and reaction. You've probably heard this phrase before. It's one of the most famous lines in all of science. What it really means is that forces are never lonely. They always come in pairs. Every single time you push on something, that something is pushing back on you just as hard. A trampoline is the perfect way to feel this law. When you jump, your feet push down on the trampoline surface. That's the action. In response, the trampoline pushes up on you with the exact same amount of force. That's the reaction. And the result? You go flying up into the air. It's actually the trampoline's pushback that sends you soaring. It's the exact same idea that makes a balloon fly all over the place when you let it go. The balloon pushes the air out the back. That's your action. And at the very same time, the air pushes the balloon forward. That's the equal and opposite reaction that makes it zip around the room. So, now that we've got all three laws on the table, let's put it all together and see how they're constantly working all around us in everything we do. So let's do a super quick recap. You've got the lazy law, which explains why things like to keep doing what they're doing. You've got the pushy law, which tells us that it takes more force to move more stuff. And finally, the bouncy law, which reminds us that every single push gets a pushback. These three simple rules, working together, explain pretty much all motion. So the next time you're in a car, or kicking a ball, or even just watching a bird fly, I want you to take a second and think about these rules. Because now that you know them, you can start to see this incredible, invisible world of forces all around you, constantly pushing and pulling and shaping everything that moves.